Yeah.
That's pretty intense.
Very.
That's funny. Okay, so number 1, it says y0 equals 0. So first you need to know that the Laplace transform is linear, which means that the sum of the
Okay.
Laplace transform is the sum of the separate ones. So you can take L of y prime plus, now the constants, it's also constant linear, so like you can take them out of the Laplace transform,
Okay.
and that's why you only see the Laplace being on the functions, okay? Because the constants can be pulled out.
Okay.
Don't start lagging. Why is it lagging?
Oh, yeah, I don't know.
It's okay.
I don't
It's, let me take the zoom out. And what else? This out has to go. Okay, it should be better. Okay. Now, the Laplace of y prime, as it says here, is s L of f minus f0. So it's going to be s L of y minus y of 0. Okay? That's just for y prime. S being the new variable. Okay? And
Okay.
then plus 5.2 L of y, which is just your new, they have it there as, they're defining L of y to be just capital Y. Okay?
Mm-hmm.
Now, for sine of 2t, okay, go back to the Pentagon Sun's home, or there, that one. Okay, go to the sine. So the Laplace of sine.
Oh, this one?
Yeah.
Wait.
So that's the right. So 1 over omega sine of omega t. What is the Laplace of that? Okay, it's gonna be 1 over s squared plus w2 omega 2. Okay.
Yeah.
So let's go back to the solution manual.
Okay.
And then notice how Laplace of sine of 2t, so the Laplace of sine of 2t is going to be 2, because of the 1 over omega is not here.
Yeah.
You're going to put it over here. So 2 times 1 over s squared plus omega, which is the number inside the parentheses,
yep.
Squared.
So that'd be just, got it. Okay.
Okay, so that's where that came from. So it's going to be 19.4 times 2 over s squared over 4. Okay, and then as we mentioned before, let me open this up. They have L of y as capital Y.
Yeah.
So it's going to be, now we know that y of 0 is 0, so we can get rid of that. And then define L of y to be capital Y. Um, 19.4 times 2 is 38.8.
Yep.
S squared plus 4. Now, like, you're solving for y, capital Y, so you factor the y out.
Okay.
And you have s plus 5.2. Okay. Then we divide this term, so it's going to be y equals 38.8 over s plus 5.2 times s squared plus 4. Okay. So now go back, scroll a little bit down so you can see the next step. From here, we will solve for what y is, but before we do that, we need to use methods of partial fractions. Okay, because
Okay.
we want to use the inverse of the Laplace transform. In order to use the inverse of the Laplace transform, you need to have these terms in isolated fractions. Okay.
Okay.
So then we get, well, calculus 2 now. If you remember from calculus 2, you have that 1 over s plus 5.2 times s squared plus 4. Since s squared plus 4 doesn't have any real roots, this one does, so it's going to be a over s plus 5.2 plus b s plus c over s squared plus 4. Okay?
Okay.
Cool. So now,
But I have a question.
go ahead.
Why did we just ignore 38.8 though? I don't get that.
We didn't ignore it. We're going to multiply this by 38.8. Okay? It's just
Okay, so that's just the last step.
yes, and
Okay.
you don't want to waste time like multiplying this number in, because we need to
True.
like cross multiply and all that, so it's just better to keep it outside. Once we figure this out, then you multiply by 38.8.
Okay.
Perfect. So now, like I mentioned, we're going to cross multiply. So finding common denominator, basically. As you might expect already, I don't like to use the letters S in math because I get confused with fives.
Yeah.
But I want to keep it simple for you. So now,
Thank you.
you're welcome. We distribute a, so a s squared plus 4a plus, and then we FOIL this. This is going to be b s squared plus 5.2 b s plus c s plus 5.2 c. Now, since you have the same denominators on both sides, you can get rid of them and just put 1, okay, which is the top number. So what's my system here? Every coefficient of s squared is going to be what? What do you think the coefficient of s squared is going to be?
I'm 0.
Very good, because there's no s squared on the left side. So
Yeah.
so the coefficients of s
Oh,
squared.
I didn't think of it that way.
Very good. And then there's an s as well. So there's coefficients for
Okay.
s. So it's going to be 5.2 b plus c. Okay. And then there's going to be coefficients for non-variables, which is going to be 4a plus 5.2 c. Okay. Now, you don't have
Okay.
to use all of them. It's just they're there for you to use. So like I mentioned, these are the coefficients, and they have to be equal to the same coefficients on the left side. Since there's no s squared, then a plus b has to be 0. Since go ahead.
No, you're fine.
Okay. Since there's no s, 5.2b plus c has to be 0. And since there is a coefficient of no variables, then that means that 4a plus 5.2c is equal to 1. Okay?
Okay.
Now we use these three to determine the unknowns. Let's start with, we can substitute b into a here and then use that to solve for a or c. Okay, so that's what I'm going to do. So b equals negative a. I'm going to substitute that into here. So 5.2 times negative a plus c equals 0. So then negative 5.2a plus c equals 0. That means that c equals 5.2a. And then I'm going to use this one to substitute it here. So then we have 4a plus 5.2 times 5.2a equals to 1. So then you get 4a
Okay.
plus, what's 5.2 times 5.2?
Wait, let's see.
That's 27.04. A equal to
Yes.
1. Now we add those two, so plus 4 is 31.04.
Wait, I have a
Go
question.
ahead.
Okay, so why is it that a plus b equals 0?
Again, these are the coefficients of this polynomial, right? S
Yeah.
squared plus s plus this whole thing.
Mm-hmm.
Since there is no s squared on the left side,
Oh, okay.
then we
A
have to
plus
we
b equals 0, and then
exactly
5.2 b plus c would also equal 0 too,
exactly.
but we just didn't show it.
No, it's right here.
Oh, you know what? I just skipped over that. Okay, never mind. Okay.
Yes. So this is the coefficient of x squared, and this one is the
Okay,
coefficient of s. This is
got
the
it.
coefficient of non-variables.
Okay.
Cool. So now we divide. We have a equals 1 divided by 31.04. That gives us 0.0322. I mean, can we make it into a fraction? Yes, I prefer that. 25 over
Okay, I get that.
776. Okay, can you verify that A for me, please, on your textbook?
Yeah.
Yep, there it is. Same thing. Okay, and then we can use A to find C and B. So C then becomes 5.2 times 25 over 776. That's gonna be equal to, in fraction form, is gonna be 65 over 388, which is
Mm-hmm.
approximately 0.16752. That's a 1. Okay, and then B is negative A, so B is going to be equal to negative 25 over 776. Okay, which again approximately negative 0.0322. Okay,
Yep.
now we plug that in into this equation. Right? So we use A,
Oh
B,
my
and
God.
C for that equation. So now we go and say, okay, this is equal to A, which was my 25 over 775
Yeah.
over S plus 5.2, and then plus B, which was negative 25 over 775 S plus C, which was 65 over 388 over S squared plus 4. Okay.
Okay.
Now we can apply the inverse function. So go back to the solution. Scroll down a little bit.
Okay.
Okay, jump all those steps. Okay, bam. So now, like, see how they wrote 38.8 in outside?
Yeah. Yeah, I see it.
Okay, that's because we started with 1 here, not 38.8. So that goes here, next to this equation. So it's going to be equal
Okay.
to 38.8 times, and then this whole thing. I'm just gonna write it real quick. I don't want to.
Yeah.
I don't trust my copy paste skills anymore.
Okay. I mean, I don't blame you.
It's not as intuitive as it should be.
There are a lot of bumps in that road.
Okay. So now that gives you that. You can multiply that 38.8 by these numbers. Okay.
Yep.
Um, it's
Okay.
it's it's up to you. But now, if you scroll a little bit lower,
Okay.
So scroll a little bit more on your solution manual.
Oh, okay. I'll bring it up right now.
So wait, no. Stay there.
Oh, what?
Stay there.
Oh, okay.
Yeah, there. Scroll down from there. Okay. Now we're gonna apply.
Quick.
Now we're gonna apply the inverse of y. Okay. So we're gonna apply the
Okay.
inverse to everything. Luckily for us, inverse functions, just like the Laplace transform, also have the rule of linearity, which means constants
Okay.
and sums can be pulled out. Okay. So it's just gonna be.
Mhm.
So we're gonna have these numbers there. So now we take the inverse function of y. Now I'm going to multiply those numbers and keep, well, I guess they already have them multiplied there, so I'm going to use those. Okay,
Okay.
1.25 L inverse of 1 over S plus 5.2, and then minus 1.25 L inverse of S over S squared plus 4. And then the last number is 3.25, so it's going to be plus 3.25 L inverse of 1 over S squared plus 4. Okay. Now, if you go back to your cheat sheet, basically, right,
Okay.
the one from the advanced, very good, the book, go to the inverse part. Okay.
I don't think I have an inverse part.
I mean, it's going backwards. It's going from like 8 to. So, okay. The inverse part is just left side to right side. So let's start with the
Okay.
1 over S plus 5.2. Notice that 7 is 1 over S minus A equals to A to negative A of t. Since it's plus,
Mm-hmm.
you're going to have 1 over S plus 5.2 equal to, well,
Okay.
it's going to be 1. Let me see if I can, there you go. Well, I'm going to write it the inverse on the top, okay? It's going to be 1.25 times 1 over S plus 5.2 is going to be E to the negative
Okay.
5.2 t. Okay, notice that A is the number and it's minus. Since we have a plus sign, in order to get a plus here, this has to be negative.
Need a minus. Yeah.
Okay,
Okay.
and then minus 1.25. Now, S over S squared plus 4. If you scroll down a little bit, go to 14 probably. Yes, 14. 14 is S over S squared plus W squared equals cosine of omega t. So that's going to be
So just because I
cosine
2t.
of 2t. Very good. And then plus 3.25. The one that is by itself is 13. It's going to be 1 over
So
omega.
1/2.
Exactly. So it's going to be 1
1/2
half
sine of 2t.
of 2t.
Oh wow. Okay. Yeah, I definitely have to print out that formula sheet.
Yep, that's why I was like, don't take it off. Very good. And that is all. That is your
Okay.
Laplace transform.
Could we do number 7?
Let's see. Number 7. It says y double prime, okay, plus 7y prime plus 12y equals 21 e to the 3t.
Mm-hmm.
Y0 equals 3.5. Okay.
Yep.
Now, apply Laplace transform immediately. Go to your cheat sheet.
Okay.
Because we need to know the one for double prime. So what is
Okay.
L of y double prime? So go.
Y double prime.
Mm-hmm.
I don't. I'm not
It's
sure.
gonna go. You'll have to go.
Oh. Okay.
Yeah, a little bit. Keep going all the way. It's not gonna be on that one. It's gonna be on the. Keep going. It's going to be on that one. There you go. Perfect.
Oh,
So,
this one.
yes. So notice how
Okay.
the Laplace of f double prime, okay, or in this case
Mm-hmm.
y prime, is s squared times L of f minus s f0 minus f prime of 0. Okay?
Yeah.
So that's what we're going to use for that part.
Okay.
So it's going to be L, so let me go here, L double prime plus 7L y prime plus 12 L of y, 21 L of e to the 3t. Okay, so like I mentioned before, it says that the second derivative is going to be that polynomial, so it's going to be s squared L of y minus s y of 0 times y of 0 minus y prime of 0, and then plus. Now that was just for y double prime. Okay. Now we have to
Okay.
do the same thing for L of y prime, which we already know from the previous one is s L of y minus f0. I'm gonna put y of 0. Okay. Then
Mm-hmm.
plus that. Now we're doing just 12 L of y.
Okay.
Now, what is L of a exponent? So go a little bit. There, it's up there actually. L of e to the at f of t. Oh no, go probably down a little bit. Keep going. Uh,
And then just goes to the table. Yeah, I'm not sure.
it seems like L of e. Oh, wait. Look at 7. L of e of
Seven.
at is
Aha.
1 over s minus
That
3.
one.
Yeah, exactly.
Okay.
And so it's going to be 21 times 1 over s minus 3. Okay?
Mm-hmm.
So now we
Wait, is
do,
that an S
that's an
of
s,
L or of 5L?
s.
Okay.
Yeah. Like I said, I don't like using s, but because that's what they're using, I don't want to be confusing
I know, it's okay. I'll just ask you to clarify. That's fine.
you. Awesome. Okay, so now I just noticed that y prime of 0 has to be defined. Let me go back to the problem. 7. Yep, there it is. We missed that one. Y prime of 0 equals negative 10. Okay, so let me put
Okay.
that there. Um, Remember, math is always right. Okay.
I mean, yeah.
Cool. So now we plug in these numbers in. Okay. So this is going to be,
Okay.
and just change this L of y for capital Y. So it's just going to be s squared capital Y minus y of 0, which is 3.5s, minus y prime of 0, which is negative 10. So I'm going to put plus 10 plus s of capital Y minus y0, which is 3.5 plus 12y equals 21 over s minus 3. Cool. Now we can add these numbers in. So it's going to be s squared y plus sy plus 12y. Now, since this one does not have a y, I can move it to the other
Mhm.
side. Okay? And then the
Okay.
10 minus 3.5 also. I'm going to move those two. So it's going to be 21 over s minus 3 plus 3.5s. Okay? And then 10 minus
Mm-hmm.
3.5 is 6.5. And then it's going to be positive on the left side, so it's going to be negative 6.5 on the right side.
Okay.
And now we can factor the y.
Cool.
Bam. So it's going to be s squared plus s plus 12 equals 21 over s minus 3 plus 3.5s minus 6.5. And then, as you already know, what will be the next step?
Well, we just factor the s's, don't we?
Not yet. We still have to
Oh,
divide this term on both on the other side.
so then we just have to find the common denominator for that side, right?
No, we don't.
Okay, you see, I'm not sure what the next step should be then.
The next step is just dividing this term on both sides.
Okay.
Yes. So it's going to be s squared plus s plus 12. Okay.
Yep.
So now it's going to be 21 over s minus 3 times s squared plus s plus 12 plus 3.5 over s squared plus s plus 12. Oop, did I miss an s? Yes, I did. Okay. 6.5.
Oh, yeah. Okay.
And then s squared plus s plus 12. Okay. Now, hopefully, this one factors into a nice factor polynomial. Is there any factors of positive 12 that add to 1?
Any components of positive 12 that add up to 1?
Factors of positive 12 that add to 1.
Oh,
I don't think there's any.
I don't think so, because I'm thinking of like, oh, wait, 3 and 4.
But they don't add to 1.
Oh, I was thinking of one of them being negative, of having like a negative 3.
Yeah, but the
But
problem
never
is
mind, that doesn't work.
Yeah. Very good. So now, since it doesn't go the easy way, let's find the discriminant to see if there's any real roots or if it's imaginary. Okay? So the discriminant here is b squared minus 4ac.
Oh, wait. They didn't get 6.5. They got 14.5.
Whoa, back it up.
Yeah.
Oh, because I missed the 7? Did I miss the 7? I did miss the 7.
I don't know where a 7 came from there, though.
There, this one.
Oh.
Yeah.
Okay.
Yeah, that will do it. Okay. So that 7 goes here and here. Okay.
Okay.
And then that 7 goes here. Yeah, I just love when I make silly mistakes like that. It's just so fun.
Oh my gosh.
It makes my day. 7. So where's this? Right here. Okay. So 7. Okay. Very good. And then we had this negative 7 times negative 3.5 is negative 24.5. And then plus 10 is negative 14.5. So we add it to the other side as plus 14.5.
Okay.
So plus 14.
Oh, wait, but they didn't have it as plus 14.5. Yes, they did. Never mind.
They did? Okay. So,
Yeah, they did.
so 14.5. And then there was, yep. So far so good. This is 7. This is 7. This is 7. Okay, and then this is 7. This is 7. And this is 7. And this is plus 13.5. 14. Okay. Now we're back in business. Now question
Cool.
the same question. Is there 2 factors of 12 that add to 7? Yes, there is. Is 4 and 3. So this is going to be s minus 3, s plus 3, s plus 4. Then plus 3.5, s, then s minus 3, s plus 3, s plus 4, and then 14.5. Oh, why do I put an equal sign then? That makes no sense. Plus S plus 3, S plus 4. Golden. Okay, verify that's correct. That is correct. Okay. So now we need to do the same thing we did on the previous example. We need to use partial fraction decomposition to break these guys up. Since they are all linear equations and they are not repeated roots, then for each factor you have a different letter. A, B, C, A, B, C, A, B, C. Okay?
Okay.
So let's do that. So on the left, so here the only one that needs a common denominator is this one, so we can just multiply by s minus 3 immediately, so that it's there. Okay. So now, check this out.
Okay.
Now that we have a common denominator, now we only have to write the numerator, right? So it's going to be 21 plus 3.5s plus 14.5 s minus 3. And that has to be equal to what? Well, the decomposition. So a over s minus 3 plus b over s plus 3, then plus c over s plus 4. Okay?
Oh, okay.
And then, you know, this is just, I don't want you to think that I'm giving you the wrong information, but that's how you start this. Now, I would suggest, let me see how they did it. Let me see real quick. Okay, they did it. Yeah, so they did it. Wait a minute. Why did they?
I kind of don't see how they did that.
Like, go up a little bit.
No, like they just went from here to just here.
Wait. I don't have that same thing for S. I did something wrong for S. Yes, I did. I added that S minus 3 there. Ah, man, that would have been a pain in the butt. Okay. So now to add that to the equation, I'll have to multiply like this. What they did is they did it separately, each one individually. I'm going to do them all at once. I mean, it's up to you how you want to do it. It's going to give you the same outcome. So let me put that factor in. So it's going to be 21 3.5 s times s minus 3, and then plus 14.5 times s minus 3. Okay? Now, check this out.
Okay.
Distribute this. Okay? Let's have it as simple as possible. So 21 plus 3.5 s squared minus, what's 3 times 3.5? Is 10.5, so negative 10.5 s plus 14.5 s minus 3 times 14.5, that's 43.5. Okay?
Okay.
And then yada 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 equal to yada yada yada. Okay? And then we add these guys up to make it very simple. So 3.5 s squared. So 14.5 minus 10.5 is 4. So plus 4s. And then negative 43.5 plus 21 is minus 22.5. And that's going to give us the same thing, s minus 3. This time I'm writing it because we're going to use it.
Okay.
And A, s minus 3, B, s plus 3, and then plus, it's lagging a little bit, I don't know why, s plus 4. Okay, so now, I'm going to teach you the same technique I taught you in calculus 2, and you probably forgot.
Yeah, I did.
So the fastest way to get A, B, and C when you have linear equations like this is
Yeah.
multiplying the factors. Okay, so for example, if we multiply by s minus 3 on both sides, it's going to cancel here, and it's going to cancel here, right?
Okay.
But it's going to be here and here, right?
Yeah.
Now, I'm just gonna do this once so you can see it, but then the other ones we're gonna do it super fast, okay? So
Got it.
I'm multiplying s minus 3 on both sides, and this is what I have left over. So in the bottom, I got rid of the s minus 3.
S plus 2 and S plus 4 because you just multiplied it to the other side.
Exactly. And then here I get b times s minus
S
3,
minus 3.
s plus 3,
Uh-huh.
and then c times s minus 3, s plus 4.
Yeah.
Okay? Now, since we got rid of that factor, you see how a is by itself?
Yeah.
I want a by itself, and by doing that, I'm going to plug in 3 for s.
Why would you plug in 3 for S though?
Because if I plug in 3, what do I get here?
Oh, you just get 0.
And here?
Yeah. Okay.
Very good. That's actually a very high level technique. But you know me, I always try to teach you the best. So we plug in 3 on these two. You get zeros. You got a by itself, but you have to plug in 3 on the left side as well. And that's how we're going to find a. It's going to be 3.5.
Oh.
3
Okay.
squared.
So when you put it on the other side, you're
4.
isolating one of the variables.
Exactly.
That's good. Because then you don't have like an undefined equation.
Here you go. Exactly. That's your a. Okay?
Okay.
So that, but again, that only happens when you have linear factors. So 3.5 times 9 plus 12 minus 22.5 is 21 over 9 times 12, which is 108. Okay? And 21 divided by 108 is 0.19. I mean, it's fine if we use those numbers. Okay, and then we're going to do the same thing for B and C. So what would I need to multiply on both sides to find B?
Well, I would have to multiply the S plus 3, no?
S plus 3, very good. So we're going to copy paste this one, but instead of in the bottom having S minus 3, S plus 3, S plus 3, and S plus 4, you're just going to have S minus 3.
Maybe negative 3, no?
There you go, and S plus 4. And then we plug in negative 3. So those two processes have to be listed. So for B, like I said, I'm going to, so for B, you have 3.5s squared plus 4s minus 22.5. And in the bottom,
can you put arrows so that I can like see which variable we're moving on to, please? Or that. That's good. Okay, cool.
And then s minus 3, s plus 4. And then I'm just going to equal to b, okay? Because you already know what's going to happen with the other terms. So yeah, what am I going to plug in?
Negative 3.
There you go. So that'll be the step. There's no square there. I don't know where I got that square from.
Yeah, I was like, wait, Josh, what are you doing?
Stop! Okay. So 3.5 times 9 minus 12 minus 22.5 is negative 3. And then negative 9 times, well, 1 is just negative 9. It's going to be 1/3. And in decimal, 1/3 is 0.33. So it's going to be 0.33 for B. Okay, then same process for C.
Okay.
So I'm going to write, the top doesn't change, so it's going to be 3.5 s squared plus 4s minus 22.5. But in the bottom, since it's s plus 4 to find c, you're going to have
It would be s minus
s
3
minus
and s plus 3.
There you go. Go to c. So what do I need to plug in?
You would need to plug in -4.
Bingo. So 3.5 -4 squared plus 4 times -4 minus 22.5. Then you get -4 minus 3, -4 plus 3 equals c. Okay. So let me plug that into the calculator. 16 times 3.5 minus 16 minus 22.5 is 17.5. And then you get -12 times -1 is just 12. So 17, so that divided by that is 1.46.
Wait, that wouldn't be 12. Because if it's -4 and -3, that's just -7. And then that would just be times -1.
Yes, yes. That's why I need you to be my co-pilot. So it's going to be positive 7. So you get 17.5 divided by 7.
It's like, wait.
Yes, yes. Okay, 2.5 it is. Let's look at the solution and see if those numbers.
And this is what they got.
Definitely not what we got. So what happened? What did I? Oh, no. Wait a minute. That was just for that fraction. But
wait, what?
What? It should be the same thing for both. Or should it? Let me see. Keep going down.
Okay.
Go. Okay.
Oh, what the fudge? Why do they have more than one A and more than one B?
Because they did it separately. That's what I was telling you.
Okay, I did not see that at all. I was like, that's
so
weird.
They did the partial fraction of 3.5s plus 14.5, and then they did the partial fraction of just 21 over the 3.
Oh, you see, I don't like that method.
But then this 1/2, 1/2, and 5/2 is what we should have gotten. So we probably did some simple math wrong somewhere. So let's hunt that situation. Yeah, so the final answer should be the same. So let's see.
Okay.
What did I... don't tell me I missed in the beginning, because then I'm going to be sad. So 21 plus 7 times s of L of y was 7 L of okay, times 7 here. So this we got correct, right? The 3.5s plus 14.5. So that's not the issue. And it's not that, okay? So
yeah.
So it's not this. And then here we were missing s minus 3. So that's true here, and that's true here, okay?
Mm-hmm.
And then this is a 5. Cool. And then we multiplied that here and that here to get a common denominator. So we got that, and then we multiply this. So 14. Okay. And then we added these guys. Let me just double check that math, because so far nothing is incorrect. So 3.5 times 3 is 10.5. 14.5 times 3 is 43.5. Okay, and negative. And then, so negative 10.5 plus 14.5 is 4. Negative 43.5 minus 21 is, negative 43.5 plus 21 is negative 22.5. That's correct. Okay. So here we plugged in 3 to find A.
Mm-hmm.
Let's see. 3.5 times 9 plus 12. Oh, there it is. I did the same mistake I did here. Remember, with the 3 plus 4, I did 12 instead of 7.
Oh.
Wild.
Okay.
Wild. Okay, so it's going to be 9 times 7. 9 times 7 is
Wait, what? That'd be 6
No, it's not
times
even
7.
9, it's 6. Oh my god, why am I doing that? 6 times
What are
7.
you doing? What is happening?
6 times 7, 42. Ay, ay, ay. It's a long day.
Okay, so 21 over
Yes,
40.
0.5. There it is.
Yeah.
Math is
Okay, that does
never,
give you 1 half.
never
Great.
wrong. Only humans. And I did the same mistake there. Look, I put 9. It's not 9, it's 6. Ah. It's negative 6 times positive 1 is negative 6. Okay? And that's
Oh, and then
1,
I give this 1 half.
1.5.
Okay.
There we go. And then 2.5.
Haha.
Aha. So you see?
But
Same
then something
thing.
happened here.
Same thing.
2.5. That's just 2.5. We've done 2 times 2 is 4. 4 plus 1. Oh, no, it checks out. It checks out. It's the same thing.
Very good. So now we substitute that in here. So it's going to be 0.5 over s minus 3, 0.5 over s plus 3, and 2.5 over s plus 4. Okay? And then we apply the Laplace transform of these guys. The inverse, okay? So L of inverse of 0.5. So again, I'm going to push the constants out. S minus 3. So 0.5 L inverse of 1 over S plus 3. And then plus 2.5 L inverse of S 1 over, ooh, whoa, relax.
What?
1 over S plus 4. I was going to make a silly mistake. Okay, now we go back to your cheat sheet.
Oh, okay.
And then if it's S minus A, it's just going to be negative.
E of A over T.
Exactly. So it's going to be 0.5 E of 3T.
Okay.
And then 0.5 E to the negative 3T. And 2.5 E to the negative 4T. And that should be your solution.
Okay. Let's